parallel, and there is series connection in parallel. So let the resistance be R1, R2, and here it will be R1, R2, R3, my dear. We found the difference. The main difference is that in series connection the current remain constant. The current remain same. Means here we can write series connection. Series connection, it is what? Parallel connection. We found the first thing that in series connection the current remain same. In series connection the current remain constant. You can write constant also, you can vary a little bit, or same. But in the case of parallel connection, we found that in parallel connection the voltage remains same. The voltage means what? The potential difference. The potential difference remain constant. या फिर you can write same. Alright. So there we found that, and we found that the potential difference vary. The potential difference vary where in series connection. So next point is that the PD means what? Is vary. That means what? The total potential difference is equal to potential difference across R1, potential difference across R2, potential difference across R3. But in the case of parallel connection, the current varies. The current varies in respective individual resistance. So what we can say, the current varies. The current varies. Yeah, yes, varies. So what we can say, the total current in the parallel connection is equal to individual respective currents in the individual resistance. That means the current across R1, current across R2, current across R3, I1, I2, I3. Clear? Clear, Vinay? Yes. So now to find the equivalent resistance in the both type of connection, what the formula we have derived it? We found that equivalent resistance here is equal to what? R equivalent means R total equivalent means total sum of all the resistance in a series connection is equal to sum of individual resistance in that circuit. But in the case of parallel connection, to find the equivalent resistance, we found how? We found 1 by R equivalent will become reciprocal of the resistance. It become what? 1 by R1 plus 1 by R2 plus 1 by R3. Clear? So this is the difference we found. To find the equivalent resistance here, we use this formula in parallel connection, but in the series connection, we use this formula. So my dear student, in which type of connection you will find the resistance is higher, in series or parallel? In which type of connection the resistance will be very high? Yeah, in the series connection the resistance will be very high. But in a parallel connection the resistance will be very less. And we know that if the resistance is more, is it good for the conduction or bad? Yeah, obviously there is a generation of heat, loss of heat, there is some detachment, there is some breakage in the circuit. That is why in the domestic appliances we use parallel connection, because we have to reduce the resistance in the domestic appliances to use many gadgets. That is why you can see whatever the voltage is there in their house. So who is the first person here? So whatever, if transformer is here, the voltage which has been getting by the first person will be getting the same voltage in the second house also. Why so? Because they are, the connection is done in a parallel way, and in a parallel way the voltage remain somewhat same. Not I can say constant, it is same. That is why if there is 100 voltage, the bulb is not glowing. Similarly, in my also home, bulb will not glow. Understood? If there is 60 volt, suppose somehow the bulb is glowing, in my home also, somehow same thing. If the fan is doing very fast, what? In that home also fan is doing very fast. Unless until there is no any defect in the fan. If there is less voltage, what happens? The fan, you can see, you can count the blades. In the count of blades, same thing will happen in the same next class also. Why? Why? Because what? Yeah, because they are connected in parallelly. And if parallelly voltages are same, if voltage is same, the working principle will also same. You can count the blades now, then also you can count the blades in the next class also. Clear? Okay, fine. So let us solve some numerical based on this topic that we have discussed here. Okay, so fine. So let me see. Share out this one.
Yes,
Is there any question from any individual candidate they can ask to clarify the doubt? Any question? Nothing.
So where do we use series connection?
Yeah, good. Thank you very much. Yeah, where do we use the series connection? Have you seen the lights in Diwalis?
Yes.
One after another, is not it?
Yes.
So what? Everything is joined like that. One bulb connected, 10. So one after another. In the same line, what? One bulb after one bulb. If you press one switch, all the bulbs glows. In that case, suppose I want to make run fan and light both at the time. So I cannot use parallel here. I have to use series. If I press one switch, both have to work at a stand. Means in a series connection, there is only one connection. Means there is only one switch we can do. But in parallel connection, there is an individual switch of particular gadgets. That is why, suppose here, if I connect one switch here, the battery is connected, okay? Here battery is connected, what happens is, I plug one switch here, I plug this switch on now, these three will go on operating. Light, TV, fan. Everything will be working if I connect in this way. But resistance will be very high. There is a chance of defect. Understood? If somehow there is one circuit breakage, no? If some sort of TV is working, not working, so nothing will work now. That is why in that lights now, in the early light, if one bulb is defect, no? If one bulb is not working or found is defective, so all other will not work. They will stop working. So you have to check the individual bulb by which is defect now. It's a very time consuming. But here it is not. If one bulb is not working, so what? Other bulb is work. So we can change the bulb. That is the benefit of parallel connection. Many benefits are there. We will discuss about it before solving some current numerical circuit. Now in parallel connection, what happens? We can use an individual switch here. This switch is the other fan, light, TV. Okay. So what if I turn it off also, they will work. But here, if TV light work, if I want to turn on the light, no, the fan will also work and TV will also work at the time. So what in parallel connection, we can use an individual connection for the individual device. Alright. So if there is any defect found in an individual device, so other will not stop working. It will work or it will not work. If one bulb is stop working, then what? It doesn't mean that fan will not run. Fan will also work properly because the connection is different. Alright. But in if one stop working, the other all will be stop working. There is some demerits, merit, advantage, disadvantage in both the connection, and we will be dealing about it. Don't worry for that. Find the equivalent resistance in both the cases. So it's a pretty simple question. What happened is that there is two cases. In first case, what happened? All the three resistances are connected in a series mode. So like that. In case one, R1, R2, R3. This R1 is how much resistance? 2 ohm. And here 2 ohm. And R3? 2 ohm. Alright. Now it is said to find the R equivalent resistance. We know that what? R equivalent in series is what? R equivalent is what? R1 plus R2 plus R3. Great. So now look here. What is R1? R1, what is the resistance R1? 2 plus 2 means ohm. 2 to 2? Yeah, the total will be 6 ohm. The total equivalent resistance of these all three will be 6 ohm. In a similar case, I have to find the three resistance total equivalent in a parallel connection. Now let us see the is what? This is the R1, R2, R3, R1, R2, R3. Now these are connected in parallel. Now it is asked to find the equivalent resistance in this mode. So how will you do it? 1 by, now the formula for the parallel connection is what? 1 by R equivalent 1 by R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So let us go putting the individual value here. So what? 1 by R equivalent, we don't know, we are going to find it here only. 1 by R1. What is R1? 2. It is what? 1, 2, 1 by 2. 1 by 2. Let us go on readily. So what is the LCM of 2 to 2? Yeah, ultimately the LCM R equivalent is equal to what? 2, 1 plus 1 plus 1. 2 is the LCM. So what? 2 1 2, 1 1 1. So 1 plus 1 plus 1. That I can put 3.
Yes.
Now I want to find R equivalent, not reciprocal of the equivalent. So R equivalent equal to 2 by 3 because I am making it reciprocal. So R so R equivalent equal to what? 2 by 3. If I cancel 2 का अगर 3 का करेगा what will
0.66.
So how much 0.006 is 0.66. Yeah. So look here. R equivalent is 0.66 ohm. Such a great difference. Such a great difference you have found here. Same thing, resistance was connected parallelly in a series. So the total resistance was 6 ohm, and the same 3 connections was done in what? In the parallelly. So you found there is vast difference, not even 1 ohm. So what's this? A great savage of electricity. Instead of wastage of electricity, I have saved electricity. The resistance is less. So as we know, resistance is less. It's a good flow of electricity, isn't it? There's no any extra loss of electricity here. That is why the parallel connection is more favorable in the domestic connection in the purpose. Clear? So you will see the question I have solved here with taking the same resistance here. So this type of question will be given to you in exam. Pretty. It's compulsory every time in every set of examination. This type of question, at least one question comes based on the connection. An electric lamp or bulb, you can consider bulb also. Electric bulb. An electric lamp or bulb whose resistance is how much? 20 ohm, and a conductor of 4 ohm resistance are connected to a 6 volt battery. So what happened is that, look here, I told you in one class that everything has a resistance. A wire, a battery, gazette, charger, bulb, everything has some resistance. So what I have done is, the question is very nice question here. So what a wire is, have to connect a bulb, and bulb, this wire and bulbs are connected with a battery. Alright, battery of how much potential difference? Yeah, this battery has 6 volt potential difference. So alright, what is the resistance of this bulb? It is 20 ohm. How much? 20 ohm. And the conductor. And what is the resistance of this? Yeah, what is the resistance of the wire? 4 ohm. So let me make this in like this. So it is 4 volt, 4 ohm. Now, what type of connection you see between the bulb and the wire? Series, one after another. So what type of resistance is equivalent resistance निकालने के लिए we will add up this. Is that it? So the connection between the bulb and the conductor is what? A series. So we'll find equivalent by series mode. So now one says that the total resistance of the circuit. So let us find it. Solution A. Here what we'll write? Here the bulb. Here the bulb. या फिर lamp. Here the lamp and a conductor are connected series way, connected in series. So therefore, what I can write? I can write that R equivalent equal to resistance of the lamp plus resistance of the conductor. Look here, instead of using R1 and R2, what I use? RL plus RC. RL means what? Resistance of the lamp plus resistance of the conductor. That is what we do. What is lamp? Lamp 20 plus 4. That is what? 24 ohm. Means what? R equivalent is equal to 24 ohm. Any problem with anyone? No sir. Now let us move to the next part. Question number B. The current through the circuit. What to find? Current through the circuit. Number 2 case, number 2b. So what to find? Current. Current is I. I is missing here. And we know from the Ohm's law that V is equal to IR. And I is equal to V by R. V by R. So what? I is equal to V by R. And what is V? V is 6. What is R? 24. Just now we found the equivalent range. So 6 by 24. If you can say 6 by 6, 6 for the? That means what? 1 by 4. That means what? 0.25. 0.25. Don't forget to write my name beginning letter. Isn't it? It's ampere. Alright. So what? That we found that I is equal to what? 0.25 ampere. I hope you got everybody. Now, next part is said that the potential difference across the electric lamp and conductor. It is said that potential difference means voltage, wave, voltage across the bulb and across the conductor. Means if you will fit one voltmeter here, what you will find the potential difference here. As we know, in a series connection, the potential difference varies. In series connection, the potential difference changes. You will not find the same potential difference here and here. You will find a different potential difference across the bulb and across the conductor. Alright, then it is asked that to find the potential difference across the bulb and across the conductor. So let us go on find again. So now let us do the part C. Shall I wrap this portion? Yes. Okay, fine. The part C says that that potential difference across what? SCRO across what? Across lamp. LAMP. So what? Potential difference across lamp. We know resistance equal to what? V by I. V by I. Alright. According to the Ohm's law, we know the V equal to IR. It is said to find the potential difference. So V is equal to IR. 0 point. And what is the resistance of the lamp? 20. It is said to find the resistance across the lamp. So we will take the resistance of only the lamp, not the conductor now. Individual resistance of the particular thing. Alright. So what it is said here? So what? 225 जो आ 50 ये 0 ये 0 दो का आगे पॉइंट था दो का आगे पॉइंट था तो क्या होगा 5 volt. That means V equal to means voltage across what? Lamp. Potential difference across the lamp is what? 5 volt. Don't be confused. A confused was being here that she was going to take resistance 24. No. But you are finding what? Potential difference across lamp. So if it is asked to find the potential difference across lamp, so we have to take a resistance of only the lamp, not the conductor. In the second part it is said that find the potential difference across the conductor now. In this case we will take the resistance of the conductor now. That is what? Now it is said now C ka 1 hai. Now C ka 2 this is what? Potential difference across what now? Conductor. Across conductor. Across conductor. That means what? Potential difference across conductor is equal to what? I into resistance of the conductor. So what is I? 0.25 into what is resistance of the conductor? 4. That means what? When you multiply with 1 ohm. You have 1 volt. That is VC is equal to what? 1 volt. Now as we know the total voltage in the series connection is equal to what? V equal to individual voltage. Now you see what is the voltage of the bulb and what is the voltage of the conductor? 5 plus 1 6 total volt 6 volt. Okay, so what that total volt is equal to what? Is equal to voltage across bulb and plus voltage across the conductor. You get see 5 plus 1 that is 6. I hope you got it. Yeah, this type of question will be given to you.